Hi, welcome to our work, Handformer2T, a lightweight regression-based model for interacting hand pose estimation from a single RGB image. The hand pose estimation and measure construction is an active research area. Given an input RGB image, we can estimate the hand pose, which is the coordinate of each hand joint, or reconstruct the hand mesh. The hand pose estimation question is widely used in AR, VR applications and human-computer interaction scenarios. Because the hand is highly articulated, the single hand pose estimation is generally difficult. Moreover, the estimation result suffers from self-occlusion. When it comes to interacting hands, the question becomes much harder because of similar appearance between two hands and hand-to-hand occlusion. Most hand pictures are single view. Estimating the 3D hand pose or mesh from a single view is an inherently ill-posed challenging problem. In this paper, we focus on the interacting hand pose estimation from single view. This problem can be formulated as a function taking an image of interacting hands as input and outputting the estimation of 3D poses of both hands. The 3D pose is composed of 3D coordinates for each key point. We have 21 key points for each hand. Existing methods can be divided into two categories, heatmap-based and regression-based. The heatmap-based methods get the final prediction by estimating a 3D heatmap for each hand key point, usually utilizing 3D CNN, while regression-based methods regress the coordinates of each hand key point directly. Generally, the regression-based methods alleviate memory issues, but suffer from worse accuracy. However, recent work on transform-based regression method achieves state-of-the-art performance as well as be memory efficient. As we can see, previous methods usually treat each key point individually, which makes no differences from the single hand pose estimation problem. Key point level tokens are also deployed in existing transformer-based methods. Yet, one should note that all existing approaches lead to quadratic computational complexity in terms of the number of the tokens. Our motivation is to decrease the number of tokens. Therefore, we propose a novel hand-level tokenization, where only one token is deployed for each hand. This reduces the total token count from 42 to 2, significantly cutting down on computational demands. With this hand-level tokenization, we design a model which consists of the following three parts. The feature extractor, which is deployed based on the backbones such as ResNet or EfficientNet. The coarse predictor, which generates a coarse hand pose prediction using residual log likelihood loss. And the last one, refiner with pose query enhancement, which refine the coarse pose prediction iteratively. Here is an overview of our model. Our model utilizes a transformer-based architecture, but with a key difference from existing methods. We propose to use novel hand-level tokens instead of key point level tokens. With rich features extracted by the feature extractor, the coarse predictor gives an initial pose prediction, which is then improved iteratively by the refiner. Let's look at them one by one. The feature extractor is composed of a backbone and several averaging and sampling operators. Given an RGB image, it outputs features from each output layer individually, referred as multi-scale features. For each feature, capital Fi at each scale, a 1D feature is obtained by concatenating the results of average pooling of capital Fi and flattened subsampling of capital Fi. In our setting, we use output layers 1, 2, 3, 4 of the backbone. Accordingly, we have 4 scales and 4 stages. At each stage, the hand-level token embeddings of the 2 hands are obtained from 2-layer MLP to fit the transformer input dimension. For the first stage, we create a coarse predictor which takes the 1D feature at the first scale and output coarse 3D coordinate prediction. With the token embeddings of the 2 hands, the coarse predictor works by passing the feature into the multi-head self-attention layer. Finally, a residual log likelihood loss is applied to supervise the training. The core part of our model is the refiner with post-query enhancement. The refiner mainly contains a key point guided feature fusion model and a post-query enhancer. Given a 3D key point prediction from previous stage and a feature map at current scale, the key point guided feature fusion model reprojects the 3D prediction to 2D image space. After obtaining the image coordinates of the hand key points, the module conducts feature indexing on the feature map, which is followed by sampling, flattening, and concatenation. This process increasingly directs our model's attention to the features located at the key points within the image. For the post-query enhancer, firstly, we update the embeddings of the hands based on previously predicted hand pose, and embeddings from the current image feature. Then, a multi-head cross-attention model is applied to get a refined prediction at stage I. We perform this refining process iteratively for 3 times. At each stage, the residual log likelihood estimation loss is applied along with the normalizing flow model. Meanwhile, a maximum mean discrepancy loss is added to the coarse predictor to accelerate the convergence. Compared to previous models, our model achieves the smallest joint error on the interhand 2.6 million dataset for interacting hands, and it is the lightest model with the second fattest FPS. It also achieves state-of-the-art performance on RHP dataset. Compared to joint-level tokenization, hand-level tokenization is both more lightweight and performs better on the interhand 2.6 million dataset subset. We also show the qualitative results. We can see that our method is better than internet. Also, the refiner with post-query enhancement is very effective in our model. Thank you for watching.